Okay, in this video we're going to talk about factoring trinomials. We're going to begin by looking at how to factor trinomials in the form x squared plus bx plus c, which means that the leading coefficient for our trinomials will be 1. So we're going to start by multiplying binomials together and look for some patterns. So I want you to take a moment, multiply these 4 sets of binomials together. You can pause the video, take your time, multiply them together, and then come back and take a look at what I have on the screen. Okay, so when you multiply these binomials together, I want you to look for some patterns. So this is what you should have after you multiplied and combined like terms for each of the 4 sets of binomials that I gave you. So for the first one, we had x plus 5 times x minus 2, and that gives you a trinomial as a product. Same thing with the other 3. We're multiplying 2 binomials together, and then we get this product. What's important about the binomials that we're multiplying is the first 2 terms are the same variable and the coefficients are both 1, so we have x times x for both of these, and that gives us x squared as the first term for each of the trinomials. If we look at the last terms in each binomial, they are just constants, and if we multiply those together, we see that we get the constant term of our trinomial. So that constant term is actually the product of the 2 constants that are in the binomials, or the 2 last terms in the binomials. 5 times negative 2 gives us negative 10. 6 times negative 8 gives us negative 48, and so forth. So that last term is just the product. But what you might have noticed as you are multiplying, when you combine like terms, that's what gives you this middle term here, and the coefficient in particular. So that coefficient, positive 3, negative 2, positive 6, negative 6, in each of these examples, is actually the sum of the last 2 terms of each binomial. 5 plus negative 2 is positive 3. 6 plus negative 8 is negative 2. 4 plus 2 is 6. Negative 5 plus negative 1 is negative 6. So the coefficient of that middle term is actually the sum of the 2 terms in our binomials. And we're going to use this pattern to help us to factor, because remember, we're going to take trinomials that look like what you see on the right hand side and go backwards. So right now we know that when we have this kind of trinomial, we're going to go back to 2 binomials. We know that if that first term is just the variable squared, that variable is going to be written in the first position of each binomial. Whatever the product of the whatever this last term is, we're going to find 2 numbers that give us that product, but we want those 2 numbers to also add to the number that you see in the middle. So let's take a look at some examples here. So we have these 3 examples that we're going to talk about factoring. So let's talk about the first one. All right, so we have q squared, we have q squared plus 2q minus 80. So we see that we have our leading coefficient is 1, we have the variable squared, the second term has a variable to the first, and the last term is a constant. So we're going to look at factors of negative 80. So what we know is that if our product is negative, that the number should have opposite signs. So we're thinking about anything that multiplies to 80, and then we're thinking about the 2 numbers that have a difference of positive 2. So off to the side, I'm just making a list of factors of 80, and then we can consider the fact that we want negative 80 by thinking about opposite signs. So just make a list of all of the factors of that constant term. So I try to put them in order, so I have 1 and 80, 2 and 40. I check to see if 3 goes in, it does not. 4 times 20, 5 times 16, check to see if 6 divides, but it doesn't. Check to see that 7 divides, but it doesn't. I have 8 times 10. And I can pretty much stop there. All right, so I'm looking in this list, and even if I don't have a list of all of them, I want to start to see, do I have a pair of numbers that has a difference in this case of positive 2. And I'm looking for a difference because I have a negative product. So that means I have opposite signs, negative 8, positive 10, and that does work. So I start to set up my binomials. The variable q goes in the first position, and those two numbers, negative 8 and positive 10, go in the last position of each binomial. It does not matter which one you put first or which one you put second. And again, you can always check by multiplying those binomials together, and when you multiply them and combine like terms, you should get the original trinomial back. In the second example, again, we're going to start with a constant, which is negative 28. So I'm listing here factors of 28. I do have a negative, so I know that those factors will be opposite in sign. So I want a difference of positive 3. And I see that if I choose 4 and 7, I can get a positive 3 if I make the 4 negative. So I can go ahead and set up my binomial. The variable here is x, so x goes in the first position of each binomial. And I'm using the two numbers negative 4 and positive 7. Again, it doesn't matter. I'm putting the positive 7 first and the negative 4 second. As long as you have the correct sign with the number, it doesn't matter which set of parentheses you put it in. All right, now this last example doesn't quite look like the others because the leading coefficient is not positive 1, but luckily it does have a GCF of negative 4. So I'm going to factor out that GCF first, which gives me the trinomial m squared plus 8m plus 12. Notice I am factoring out the negatives. So that makes that first term positive 1, which is what I want. So now I'm looking for factors of 12. This negative 4 is a GCF that's just going to come down. I'm setting up my binomial. So my list of factors of 12 are 1 and 12, 2 and 6, 3 and 4. And I want a pair that add up to 8 because my sign should be the same. I have a positive 12. 2 and 6 does that, so I have m plus 2 and m plus 6. All right, now things can get a little tricky if you have a trinomial where the leading coefficient is not 1. So we're looking at trinomials where we have some other value other than positive 1 here, and we cannot take out a GCF. So we're going to take a look and explore this first example by kind of thinking about it in terms of trial and error. Okay, now I know I'm going to have two binomials, and from what we did before, I know that I can look at the constant term to find factors, but I also need to think about factors of the first term as well. So I'm making a list of factors of the leading coefficient and the constant term. And they both happen to be 6 in this case, but they don't have to be the same. So the factors of these are 1 and 6 or 2 and 3. So I'm thinking about all possible factorizations. I'm thinking about all possible combinations of the coefficients that I could put in place. Now I have 4 positions to fill in. The first position for each binomial and the second position for each binomial. So let's say I pick 1 and 6 first. So I'm going to think about 1x and 6x and then put all different combinations of the other factors for 6. I'm not worrying about the signs right now. Let me pause this for a second. All right, so I could put the 1x with a 1 here, and then the 6x with the 6 here. And right now I'm just listing all the combinations. I'm not going to check if they work yet. All right, so let me go ahead and just fast forward this a little bit so you could see all the different combinations. So I'm writing all the combinations that I can possibly put down using the factors of 1 and 6 and 2 and 3. Okay, now I can start to get rid of some of these. Now, I did not have a GCF to begin with. There was no number that divided all 3 terms, so none of my factors should have a GCF in them. So what I'm doing is I'm crossing out all of the cases that have a GCF within the binomial. So if there's a GCF in the binomial, that can't possibly be the factorization. So that does help me get rid of some of them, but I still have 2 that I need to just try out, and I could try by multiplying. So I know the first two terms, 1x times 6x gives me 6x squared. And I also know the last two terms work. 6 times 1 is 6. But it's the inside and the outside terms that I am not sure about. So the inside terms here give me 36x. The outside terms give me 1x. And I can get a negative 37x if I make both of those negative. Now, if I make both of those negative, that means that in the parentheses, I need to have negative signs, which does give me a positive 6 here. So I do know that that is the correct factorization. However, I can also check that last one just to see that it doesn't work. And when I do the inside and the outside terms, I have 9x and 4x, and that in no way would give me a 37x if I combine like terms. Now, this process is fine, but it's time consuming. So we have a better, well, not necessarily better, but a faster way of finding the factorization for a trinomial like this. Just go forward here. All right, so here we have 3 examples. So let's take a look at the first one. So what I'm going to do is actually multiply the first term by the last, 3 times negative 6. And that is going to give me the product that I'm looking for. That gives me negative 18. So I'm listing factors of negative 18 that will also add to negative 7. So I see that I have a pair of factors that does add up to negative 7. And when I say add, I'm thinking about opposite signs because I have a negative 18. So I know that 2 and 9, if I make the 2 negative and the 9 positive, those will combine to 7. I'm going to use that to change my trinomial into a polynomial with 4 terms. The coefficients of the 2 middle terms will be the negative 2 and the positive 9. I'm just splitting it up so that the first 2 terms have something in common and the second 2 terms have something in common. And then once I go ahead and do that, I'm going to use the method for grouping. So I'm grouping the first 2 and the second 2, putting the plus sign in between. In the first group, I have a GCF of 3x, dividing everything by 3x. In the second group, I have a GCF of negative 2y. And then when I divide by negative 2y, I have also x plus 3y. Notice that what I have in the parentheses is exactly the same, so that is now my GCF, x plus 3y, and then what's left over outside of the parentheses goes in the second binomial. Now once again, if you multiply these 2 binomials together, you will get the original back when you combine like terms. All right, let's take a look at the next example. I'm going to multiply 12 times negative 15. That gives me negative 180. So I'm looking at factors of negative 180, thinking about the fact that I will have opposite signs. So I want 2 numbers that actually have a difference of positive 11. And those 2 numbers will be 9 and 20. So I'm using the 9 and the 20 to break up that middle term of 11p. I'm just listing more factors here, but once you find the factors that work, you don't have to list the rest of them. So I'm going to take those 2 coefficients, negative 9, positive 20, give me positive 11, and I'm just splitting that up into 2 terms, negative 9p plus 20p minus 15, and then going ahead and grouping the first 2, grouping the second 2. In that first group, my GCF is 3p. In the second group, my GCF is 5. Notice that, or just 5, not a 5p. When I do factor, my binomial is exactly the same inside. Oops. So my factorization, 4p minus 3 and 3p plus 5. I'm going to fast forward this last example and let you take a look at what's here, but there is a GCF there first. So you would have to factor out that GCF before you go ahead and use the method for grouping.